In this video, we're going to take a look at a fairly common optimization problem. Okay, so the question says a farmer has 460 meters of fencing to fence 4 equal rectangular fields as shown in the diagram. What are the dimensions of the field such that she fences the greatest area? What is the maximum area that she can enclose? Okay, so we're looking for the dimensions of the field, and we're also looking for the maximum area that she can enclose. So we'll begin by assigning variables. So we're going to let x represent the width and y will represent the length. So x representing the width, so this is going to be the width of the field, and this is going to be the length of the field. Okay, so this would also be x. Okay, so all these lines are represented by x. Okay, and this line here is represented by y. So after assigning variables, we're now going to set up an equation for the perimeter. So the perimeter in this case represents the total fencing used. So we're going to have 5x plus 2y is equal to 460. Right, so we have 5 x's here, okay, and we have 2 y's, okay, and the total fencing used is 460. So now we're going to set up an equation for the area of the field. Okay, so the total area of the field, and so the total area of the field is equal to the width times the length. Okay, so x times y. Now we're going to express the length y in terms of the width x. Okay, so we want to only have one variable. So right now this equation has 2 variables, but we want it to only have one. So rearranging this equation, so we're going to have 2y is equal to 460 minus 5x, and then we're going to isolate for y. So y is going to equal 460 minus 5x divided by 2. Okay, so simplifying further, we're going to have y is equal to 230 minus 5 over 2x. So now we're going to express the area in terms of the width. Okay, so we're going to have a of x is equal to x. So basically taking this equation and we're replacing the y with this expression. Okay, so x times 200. So x times 230 minus 5 over 2x. Okay, now we're going to distribute the x in to give us a of x is equal to 230x minus 5 over 2x squared. Okay, so now we have the function for that represents the area of the rectangular field. Now, in order to find the maximum of this function, so the maximum area, there are 2 methods. So the first method is by completing the square, and the second method involves using the factored equation to find the maximum. Okay, so we're going to first try finding the maximum by completing the square. Okay, so method 1, completing the square, to change the equation from standard form to vertex form. So we start with our equation in standard form. So this is a quadratic equation. And the first thing we're going to do is we're going to factor out negative 5 over 2 from both terms. Okay, so we're factoring out the leading coefficient. Then what we're going to do is we're going to add and subtract b over 2 squared inside the bracket. So we're going to take 92, okay, divided by 2, and then square it to give us 2,116. Okay, so if we add it, we also have to subtract it. Okay, so we can't just add something to an equation. So in this case, it's almost like we're not really adding anything, because we're adding it and then we're subtracting it. Okay, so we haven't changed the equation. So now we're going to take the negative 2,116 out of the bracket. Okay, and when we take it out of the bracket, we have to multiply it by the negative 5 over 2 in front. Okay, because everything that's inside of this bracket is being multiplied by the negative 5 over 2 in front. Okay, and so what we're going to get is we're going to get so this part, and then plus 5,290. Okay, and so now we're going to factor the trinomial that we have here in the bracket to create a perfect square. Okay, so this x squared minus 92x plus 2,116 can be factored to x minus 46 squared. Okay, so if you were to expand this bracket, so if you were to multiply it by itself, you would go back to this expression. Okay, so now this is in vertex form. Okay, so we have the x coordinate of the vertex, which is 46, and we have the y coordinate of the vertex, which is 5,290. Okay, and so we're going to use the perimeter equation to find the length by substituting in the width. Okay, so we know that the width represented by x is going to be 46. And so going back to our perimeter equation, substituting in 46 for x, we're going to so simplify this, isolate for y, and so we get that y is equal to 115. Okay, and so we can conclude that the dimensions of the field that give a maximum area are 46 meters by 115 meters. And the maximum area is that can be enclosed is 5,290 meters squared. Okay, so this is one method of finding the dimensions and finding the maximum area. Now we're going to look at the other method. So the other method involves using the factored equation to find the vertex. Okay, so we begin with the factored equation, and now what we're going to do is we're going to find the roots of this equation, or also known as the x-intercepts of this equation, by setting this equation equal to 0. Okay, so we set it equal to 0, and so one of our roots is going to be 0, and the other one is going to be 92. Okay, so our two x-intercepts or roots are 0 and 92. Now we're going to find the middle value between the two x-intercepts by averaging them. Okay, so 0 plus 92 divided by 2 gives us 46. Okay, and so this middle value gives us the equation of the axis of symmetry, which is the x-coordinate of the vertex. Okay, and so now we're going to substitute this value into the area formula. Okay, so into the factored area formula to get the maximum area, which is the y coordinate of the vertex. Okay, So we substitute in 46 into the factored equation, and we get 5,290. Okay, so same as what we got with method 1. Okay, so this confirms that the numbers that we got using method 1 were correct, because using method 2 we get the same values. Okay, so once again you'll have to use the preliminary equation to find the length as was shown in method 1. So now let's take a look at how the area function actually looks like. So it's a parabola. It's reflected, so it's opening down, and so our axis of symmetry is 46, and our maximum value is 5,290. Okay, so the width is 46, and the maximum area is 5,290. Okay, thank you for watching.